Hello, my name is Wilmer Escobar, and today I'll be showing you how to do a repeat chemistry problem. Our problem says methane gas reacts with chlorine gas to form dichloromethane and hydrogen chloride as shown in the reaction. And this right here is our reaction. The problem also states that a 25-gram sample of methane gas is placed in a reaction vessel containing 2.58 mole of chlorine. And this is our given. So first we are asked to identify the limiting reactant when the methane and chlorine gases are combined. So like I said, we're given that there is 2.58 mole of chlorine, and in order to get to methane, we have to do the molar ratio, which we can get from the coefficient in our reaction, and that would be 1 mole of methane over 2 moles of chlorine, and when we calculate this, we get 1.29 moles of methane. And we are also given 25 grams of methane, and in order to find the amount of moles of chlorine that reacts, first we have to convert the 25 grams of methane into moles, so we divide by the molar mass of methane, which is 16.04. Then we do the molar ratio, which again we get from the coefficients of our reaction, and that would be 2 moles of chlorine over 1 mole of methane, and when we calculate this, we get 3.12 moles of chlorine, and as you can see, this amount is less than this amount, so our limiting reactant would be 2.58 moles of chlorine. So next we are asked to calculate the total number of moles of CH2Cl2 in the container after the limiting reactant has been consumed. And we do this by using the limiting reactant amount, which is 2.58 moles of chlorine, and we convert that to moles of CH2Cl2 by using the molar ratio, which again we get from our reaction, the coefficients in our reaction, and that would be 1 mole of CH2Cl2 over 2 moles of CO2, and we get 1.29 moles of CH2Cl2. The next part to our problem says iron reacts with oxygen to produce iron oxide as represented by the equation above, which we have here. It also says that a 75-gram sample of iron is mixed with 11.5 liters of oxygen at 2.66 atm and 298 Kelvin. So we are given 75 grams of iron, 11.5 liters of oxygen, 2.66 atm, and 298 Kelvin. First off, we are asked to calculate the moles of iron and oxygen before the reaction begins. So to find the moles of iron, we use the 75 grams given to us, and we multiply that by the amount of moles, which is 1, and divided by the molar mass in order to find the moles, and the molar mass is 55.85 grams, and when we calculate this, we get 1.34 moles of iron. And to find the moles of oxygen, we use the equation PV equals nRT, and we manipulate the equation so that it looks like this, which is moles equals PV over RT, and when we substitute the numbers given to us, we get 2.66 atm times 11.5 liters divided by 0.0821, which is R, times 298 Kelvin, and when we calculate this, we get 1.25 moles of oxygen. Next, we are asked to identify the limiting reactant when mixture is heated to produce F2O3, which is shown on our equation right there. And so we do this by using the moles of Fe that we calculated before. So we do 1.34 moles times the molar ratio, which is 1 mole of Fe2O3 over 2 moles of Fe, which we get from the coefficients in our equation. And when we calculate this, we get 0.67 moles of Fe2O3. And now we need to do the other amount, which is 1.25 moles of O2. And again, we use a molar ratio, which we get from our equation over here. And that would be 1 mole of Fe2O3 over 1.5 moles of O2. And when we calculate this, we get 0.83 moles of Fe2O3. And as you can see, again, this amount is smaller than this amount, which means that our limiting reactant would be 1.34 moles of Fe. That would be the end of our AP problem. Thank you for watching.